Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Stephen Feuerstein, and I'm a PL/SQL developer just like you. This lesson is part of my series on bulk processing in Oracle PLSQL, one of the most critical areas of performance enhancement in the PL/SQL language. And the focus of this lesson is change data faster with the for-all statement, which I consider to be the most important enhancement in PLSQL since way back in Oracle 8i. Really great stuff. You want to look for every opportunity to apply it. But before you do that, you have to know how it works. So let's take a close look. First of all, a couple of quick reminders. You can download from my PL/SQL Obsession site, toadworld.com/sf, my initials, all the supporting code that I'll be running and the PowerPoint documents that are for this webinar, this lesson, and many others. So do take advantage of those resources. And make sure you're comfortable with the material covered in the previous lessons in this series, particularly the introduction to bulk processing, why it's important, why it makes such a difference in the performance of your applications. Get data faster with bulk collect, so learn how to retrieve data from the database into tables much faster than before. And then you're ready to take a look at for-all, which involves taking data inside your PL/SQL programs and moving them into the database tables much faster. The agenda. We'll start with an introduction to for-all, the syntax, how it works, and how performant it is. Then we'll take a look at the SQL% bulk row count pseudo collection, which is a new SQL attribute that allows you to find out how many rows were modified by each individual statement. We'll take a look at issues of referencing fields of collections of records, one of the limitations on for-all, at least before Oracle 11. And we'll take a look at how to use for-all with sparsely filled collections, one of the more advanced features of for-all. Finally, regarding for-all and error management, there is a special clause for for-all called save exceptions, and this is covered in detail in the error management video series. So we're not going to cover it in this series, but rather in the error management series, so make sure you watch that video. Okay, so using for-all for multi-row DML operations. So the basic idea is that you want to look for loops that contain inserts, updates, deletes, or merges. So cursor for loops with individual inserts, etc., and convert them to for-all statements. So a for-all statement is like an extended DML statement. The header looks identical, at least in the simplest case, to a numeric for loop. And then inside the for-all statement, you have an implicitly declared DML operation. So underneath the for-all header, we have a DML statement. And at least one place inside that DML statement, you need to have a bind array. So let's take a look. So as with a for loop, numeric for loop, with a for-all statement, you have an implicitly declared iterator, an integer, the index value. You can name it whatever you want. You don't have to declare it. Oracle does it for you. You then have a range of values, and we'll look at an alternative to this format later on in this section. But the standard approach is a numeric range of values from low value to high value. Somewhere inside your DML statement that's attached to the for-all statement, you'll reference a bind array, a collection of values. And the index for that collection of values has to be the implicitly declared iterator. And once you set it up this way, you basically are telling Oracle at a very high level, a very declarative level, okay, take over for me. You know what I want to do. I want you to find for every element in my bind array, I want you to generate a DML statement and then execute all those DML statements with one context switch in the SQL engine. The issue of context switches and how that works is covered in the first element, the first video in this series, Introduction to Bulk Processing. So if you're not sure what I mean by a context switch, definitely check out that first video. But that's pretty much it. Simply by putting your DML statement under your for-all header, referencing your iterator in at least one place in your DML statement, and can be multiple places, Oracle will automatically transform the performance profile of your DML operations, and you'll see enormous benefits from the standpoint of performance. In fact, let's take a look. So the for-all timing script is in the demo zip file that you can download from my PL/SQL Obsession site, and you'll find a number of statements to create tables and then compare the performance of inserting. So let's take a quick look at the script, then I do encourage you to run it yourself as well and verify the same kind of performance benefits in your environment. So what I'm going to do is for the part number, part name table, I'm going to create nested tables, collections inside my compare inserting procedure. And if you're not familiar with collections, you should definitely stop and watch the videos and study up on collections because they're critical to using for all. And I populate my collections with a lot of data. Now, what I'm going to do is compare the performance of doing individual inserts. So for index to 1 to 10,000 or 100,000, insert into the parts table, and then specify the values. This is an example of row by row inserting. And I'll compare that to a for all insert. So here's that same insert statement, but instead of using a for loop, I'm going to use a for all statement. Everything else about this statement is exactly the same. I've already used collections, so I reference my collections here. Notice the iterator is referenced in this collection and in the second collection. It can be more than one. And then we'll take a look at the difference in performance. And by the way I do that, the way I compare performance, is with the SF timer package, a utility that uses DBMS utility getTime to calculate elapsed time down to the 100th of a second. And you can install this from the demo zip file as well on PLSQL Obsession. So I'll compare row by row inserting with for all bulk inserting. I've also got a few different approaches here. I'm doing an insert select, which is directly inside SQL, using the table operator against my nested table. I've also got a variety of other things here like insert select, not using anything in PL/SQL, but simply looking at the raw performance of an insert select, which is pretty much always going to be the fastest way to move data from one table to another. And then I'll do full bulk collect for all processing. So grab all the data from the table and then do a for all insert. So this is just to give you a sense of the different approaches that I can take to do these bulk inserts. And when you run this on Oracle 11, this is the kind of performance results you'll see. The for loop, inserting things row by row, 3.8 seconds. For all bulk processing, 100,000 rows inserted in 0.09 seconds. That's amazing. All I've changed is the way that the PL/SQL code communicates with the SQL layer, and look at that boost in performance. And if we look at some of these others, if I do an insert select from a nested table using the table operator, it's slower, but it's still much faster than the row by row insert. And the only thing that's faster than the for all statement here is the insert select 100% SQL, simply moving data from one table to another without any PLSQL. And notice the performance, just a little bit faster than the for all statement. Now again, you should run the script yourself. You should verify this kind of performance in your environment, your database version. And in fact, if you're not in Oracle 11 yet, you're going to see an even bigger difference. This is probably about 10 seconds. It'll be 100 times faster to use for all. So run the script to verify that you will see lightning fast performance, and this will be great motivation to you to look for every opportunity to apply the for all statement. And take a look at each of these different implementations. Now, in this particular case, converting from what I would call old-fashioned code, row by row inserting, to the for all statement, high performance inserting, is trivial. I change for to for all. I get rid of loop and end loop because it's not a loop anymore. It's an extended DML statement. And I'm done. I've finished my conversion. Well, in the real world, you're not going to run into conversions as easy as this. There are many, many other issues to deal with, and in fact, the next and last video in this series focuses solely on what it takes to convert from the old-fashioned code to the new way of doing things. So in this case, the conversion is trivial. In most cases, it's very much not trivial. But as you can see, the performance profile is nothing short of amazing. Let's take a look at a couple of other examples of the for all statement, just to give you an additional comfort level about using it, and then we'll be exploring it in much more detail as well. Here's an example of using a single bind array. So I've declared a couple of collections, the list of employee IDs, the list of employee names. I populate my two arrays with data, and notice the index values correspond. And then inside my for all statement, in this case, all I'm saying is just use the IDs. I'm going to delete from the employees table. So for all index in 1 to the count go through all the elements in my list of IDs, delete from the employees table where the employee ID equals that value. And again, Oracle takes over and completely changes the execution profile just by using the for all statement. I can change this to whatever I want, but that name has to match, has to be in there somewhere. In fact, let's give it a try. So let's first of all get rid of the names because I actually don't need them here. That's a little bit of improvement in my scripts. Let's grab that code out. We'll run it here. So delete those rows, and then I'm going to roll back the changes. And in fact, let's also add the ability to see how many rows were modified. So SQL percent row count. So when I run this code, whoops, integrity constraint, I can't do a delete. Okay, so I won't do the delete operation here, but if I didn't have a match on these names, I would get an error. Let's see if I can get that error right away. When I try to run this code, notice L-index2 must be declared. So the names have to match between this one and this one for the for all statement to work. And then it takes over from there. Here's another example with multiple bind arrays. Now in this case, I am using IDs and names. So list of IDs, list of names, and I'm going to update the employees table, setting the last name equal to the new name for that ID. So what you can see here is that you can have multiple bind arrays in the same for all statement, and Oracle will automatically correlate them. So you have to have matching index values here. For every index, since I'm driving it with the IDs list, for 1 and 2, I'd have to find a matching element here. And this we should be able to run and not run into problems. So let's do that. We'll again take a look at the number of rows modified. Run my DML statement, and we should see 2 rows modified. Now, if I didn't have matching values in each one of those, so I have 1, 2 in my IDs, 1, 3 in my names, let's see what happens. Element at index 2 does not exist, so it tried to find a match. It tried to find an element in L names at index value 2, couldn't find it because it was 3, and then we get the error. So you have to make sure those all match up. Usually, what you'll do is fill them up with a bulk collect operation, and they'll automatically correlate. But if you're building them yourselves programmatically, make sure that every element in your different bind arrays that are referenced in your for all statement all correlate across. So that's the basic idea behind the for all statement. And there's one other comment here at the bottom. You can also use a different header style with indices of and values of, and I'll be talking about that a bit later. So some more details on for all. You can use it with any type of collection with for all. So nested tables, V-arrays, associative arrays. Only one DML statement is allowed per for all. This is probably the biggest restriction and biggest complication for all statements. If you have multiple DML operations for a single transaction and you want to bulkify that process, you have to have separate for all statements for each one. And we'll be taking a look at the complications there and how to address them in the next and last lesson in this video series, converting from old-fashioned to modern bulk collect operations. The collection must be indexed by integer. Any of your bind arrays must be indexed by integer. No indexing by string allowed. And the bind array must be sequentially filled unless you use the indices of or values of clause. You actually just saw that in this example here. Or the better way to express it is if I have any missing values, so let's add a third to this one and a third to this one. So now we've got 3 rows in each one. If for some reason we end up with a gap, a missing value. So if I get rid of 2, so now there's 1, there's something defined at 1, something defined at 3, and we're going to go from 1 to 3. As soon as it hits that missing location, you'll see the error that we just saw before. Element at index 2 does not exist. So when you're using the for all index in from low to high, in other words, the same thing as the numeric header, you have to make sure that every element between first and last are defined. And if you have gaps, for all will raise errors. And the way to get around that is using indices of and values of, which is coming up. All right, let's take a look at the for all restriction script. See if there's anything we missed. So the bind array must be integer indexed. If I try to run a script that uses a string index collection, it just tells me this is not supported. You have to index by integer. Only one DML statement is allowed per for all. So in some cases, I might easily have multiple DML operations in the same statement or the same transaction, and I want to bulkify both of them. So this is the sort of thing you'd like to do, but when you try to do it, Oracle doesn't let you. And you'll get different errors depending on how you try to structure it. But the bottom line is one DML statement per for all. When you get to that semicolon, you've terminated the entire for all statement, not the individual DML statement. So that will not be allowed. The bind array must be densely filled. I just showed you the example of this. If there's a gap, it will not process. You'll get the element at index does not exist error. Indexes cannot be expressions. So you can't do fancy stuff inside your for all statement. Here's an example of trying to multiply by 2 the index value because I only want to update the even valued rows. Who knows? And if I try to do this, for all iteration variable index is not allowed in this context, so it simply doesn't let me do that. You can only reference the iterator as itself. So various kinds of restrictions. Again, I encourage you to run these scripts yourself, play around with the for all statement, get a good solid understanding of how you can use it, how you can't. All right, let's take a look at the SQL% bulk row count attribute and how it can help you. First of all, SQL% row count, hopefully you're all familiar with that, is an implicit cursor attribute that returns the total number of rows modified by the entire for all. In general, SQL% row count returns the number of rows modified by the most recently executed SQL operation in your session. And the point to remember here is that SQL% row count, when you're talking about for all, applies to the entire for all statement, not the last statement executed within the for all. Note also that if you're using the log errors clause, which is another way to suppress errors at the row level, check out the error management video series for more details, then the number that's returned by SQL% row count is not to be relied upon. But in general, SQL% row count returns the total number of rows modified by that for all statement. Well, that might not be all the information you need. My for all statement might have executed 10 individual DML operations, and I need to know how many rows were modified by each individual operation. And for that, we have the SQL% bulk row count cursor attribute, which is actually a pseudo collection. It looks like and acts a bit like a list of integers. It's called a pseudo collection because Oracle creates it for us. We don't declare it. And it has a partial implementation. There are no methods declared on the element. On this element, you can't do counts and first and last and so on. You'll see that and understand that when we take a look at the example. But again, use % row count to figure out how many rows were modified by each individual statement executed by the for all statement. Let's take a look. So in this example, I'm going to create a nested table of integers at the schema level. And then within my anonymous block, I'll declare a list of employee last names. And I'll create that as a filter. I'll use that type as a filter. I want to find everybody whose name starts with S, whose name starts with E, whose name contains an A. Let's take a look at the for all statement. It's a fairly complicated one. For all my filters, the 3 that I just showed you, I'm going to execute an update statement. I'm going to say, give everybody a 10% raise if their name matches this filter. Sounds like a ridiculous reason to get a raise, right? But I bet you've seen situations in your own companies where you wonder, why did that person get a raise? And the answer can be fairly arbitrary. So here's a truly arbitrary criteria for giving a raise. If your name matches one of these filters. Now, what I'd like to do, in addition to executing my update statement, and it will execute the update statement 3 times because I have 3 filters, I want to get the employee IDs of everybody who got a raise. So I can use the returning clause with my DML operation to retrieve information about the column values of the rows that were modified. Now, returning has nothing to do with for all. It was added in Oracle 8 as a way to retrieve information back from your DML operation without doing a separate select, an extra context switch. So I'm saying, get me the employee IDs of all the rows modified by these update statements. Now, because there could be more than one, I can't say returning employee ID into employee variable, I have to say returning bulk collect into. So here's an example of using for all with bulk collect into. And I populate my list of numbers. After running my for all statement, I'll find out the total number of rows modified by the for all statement itself. But then I want to find out the number of rows modified by each individual statement. So for each of the filters, in other words, for each of my binding array values, get the value from SQL% bulk row count at that index. So you can't say go from 1 to count of bulk row count. None of those methods are defined. You always work from the bind array because the number of rows are per bind array element, per statement executed. So I'll display the number of rows modified for each element, for each filter. Then just to show you it's possible, I will display all the employee IDs that were modified. That's fine. And then I'm going to create a table dynamically using dynamic DDL, create an employee number temp table, and I'm going to use for all with dynamic SQL. I can use it with dynamic and static SQL. Simply use execute immediate underneath for all. There's my dynamic insert statement. Notice I have a bind variable, a placeholder, and in my using clause I will bind my element from my collection. So there's my iterator, repeated here. There's my bind array. So this is an example of how you do these operations, these dynamic operations, with for all. I run my script, take a look at the results, and I find that a total number of rows modified by this statement are 68. And notice I have my per statement numbers, 9 starting with S, 3 starting with E, 56 containing an A for a total of 68. There are my 68 employee IDs, and if I take a look at my schema browser and the employee empno temp table, what I find is that I have 68 rows in my table. These were all inserted dynamically using execute immediate and for all. So all these things are possible, and the SQL% row count in particular gives you access to that detailed information about the number of rows modified per statement. Let's talk about one big restriction on for all prior to Oracle 11, and that is you cannot reference a field of a record inside a for all statement. Let's take a look at the example. Be clear about the problem. Now, bulk collect easily lets you bulk collect into a collection of records. So here's an example of selecting 2 columns out of my table. I've created a user-defined record type that has just those 2 columns. I've created my collection based on that list of records. And I can say select bulk collect into that collection. No problem. Bulk collections of records supported for an awfully long time inside PLSQL. What I cannot do prior to 11.1, Oracle 11G, is reference a field of a collection of records inside a for all statement. If you try to do this in Oracle 9 or Oracle 10, Oracle raises the implementation restriction error, -436, cannot reference fields of bulk in bind. So this is not allowed prior to Oracle 11. In Oracle 11G, Oracle now supports this, and so you can use it with no problem. Prior to Oracle 11, what you have to do is break up your collection of records into individual collections of column level data and then reference them each separately, which is really quite unfortunate. You'll see an example of this in the next lesson, which is converting from old-fashioned to the more modern code with bulk processing. But prior to 11, you can bulk collect into collections of records, but if your intention is to use that collection of records inside a for all statement, you'll have to bulk collect into individual collections. Now, another possible way to get around this problem and having to go through all this extra work is take advantage of row-level operations. So in case you didn't know, since Oracle 9i Release 2, I can do inserts at the record level, and I can do updates at the record level. So here's an example of using for all. Insert into the employees table, and as my value, I'm not going to pass a list of individual values, which is what you would be doing if you had parentheses after the values keyword. In this case, no parentheses. I just provide the record, and it will dump that entire record as a row into the table. So if you don't need to select out individual columns, if you're working with a table of a collection of table % row type element types, So every element in the collection matches a row in the table. You can take advantage of row level operations, and perhaps you can avoid having to break out your collection of records into individual collections of scalar values or column values. If you want to update at the row level, you can say set row equals, and that will take every element in your collection, every field in your collection of records, and update every single corresponding column. So to sum up, prior to 11G, you cannot reference a field of a record in for all. You have to break up your data, break up your collection of records into separate collections. Look to see if you can take advantage of record level inserts and updates. And in 11G, this restriction is lifted, but note that at least in 11.1, it is not documented. So you can only hear about it here. Probably in 11.2, the documentation has been added, though I cannot verify that at this moment. Okay, using for all with sparse collections. Now, prior to Oracle 10.2, the binding array in a for all statement had to be sequentially filled. In other words, if you had any gaps between the low and the high values, Oracle would raise an error, which we've already taken a look at, but let's revisit that for a moment. The bind array must be integer index, here we go, must be densely filled. So if there's a gap between low and high, then Oracle will raise an error telling you that you've got a missing value, and that's no good. So that's what this error means. Element at index n does not exist means there's a gap between low and high. Now prior to 10.2, the only thing you could do is reorganize the content of your collection to get rid of the gap in your collection. I'm assuming that you are on 10.2 or higher. Just about everybody is in 2010. So what you can do instead of having to reorganize the content of your collection is you can use the indices of or values of headers. You can change the way that you specify the indexes to be used inside the for all statement. Here's the simplest form you can use. In this case, notice I have my for all statement with my iterator index. In my DML statement, I reference the list of emps. That's my bind array, and there's my iterator by name. So that's all the same thing you've seen before. But what if my list of emps has gaps in it? Well, what I can do is simply say in the indices of that collection, so I can reference the bind array in my indices of clause, and this simply says, Oracle, if there's any gaps, if there's nothing between the first and the last, then don't worry about it. Just skip over anything that's undefined, and it will only use those indexes defined inside my indices of clause collection. Let's take a look at a more interesting example in the 10G indices of script, and then we'll take a look at values of as well. As I say, this is the simplest form. The bind array is the collection that I use in my indices of clause, but it doesn't have to be that way. I can even get a little bit more fancy, you might say. Whoops, if I can only type. In this particular use of indices of, notice my bind array is called L-employees, but my indices of collection is called employee indices. Suppose I have a list of employees that's thousands of elements long, and I have this very complex algorithm that determines which of those thousands of employee IDs I'll actually be performing the update on. Now what I could do is run through that collection and delete out everything that shouldn't get the update. But I might need the same collection for multiple reasons, so I can't remove the data from it. What I can do is build an alternative index into my bind array, and in this index, in this collection, define all the elements, all the index values that should be updated. So the indices of collection always has to be indexed by integer. The data type of the elements in that collection are unimportant. They could be anything. We don't actually use them. We only look at what index values are defined. So in my script here, I've got my employee IDs list, 137, 126, 147. I have my index values, and the elements that are defined are rows 1, 500, and 799. In my for all statement, I say only use the indexes defined in that index collection. And here's a between clause. I can specify a between clause that says only use this range of values. So when I execute this statement, what it should say is, okay, between 1 and 600, let's see what we've got. We've got 1, so I go back to 1 and update for this row. We've got 500, so I go to this element an update for this row. I skip over 100, and notice I never use 799 at all. So what should happen is that I see an update for this one and this one, but not this one. And we'll verify that by running a select statement before and after. I run my script. I look at my script output, and notice 137 and 147 now have that expanded salary value, 2 more than before, but the other one, 126, was not updated. So as you can see, indices of gives you this incredible flexibility to very finely tune the access into your bind array to determine which index values should be affected or used in the DML operation. Now, values of is even more indirect. I've never had an opportunity to use it myself, but I'll show you how it works. Instead of indices of, I specify values of. So bind array, the values of collection. In this case, the values of collection has to be a table or collection of integers indexed by integer, because what's important here is the value in an element in the collection, not the index value. So with this format, I say is in values of, and when it executes the statement, it looks to see for each of the elements specified what is the value at that level, and then it uses this value to find the element inside the bind array. So it should do an update for minus 77, 134. It should do an update for 1367, which would be 123, and an update for 1070, which should be 129, but it will not do an update for 147. And now when I run this script, I should see that 147 did not get an increase. So we've added 3 rows, 123, 129, 134, but we did not add 147. So again, values of gives you this very flexible approach. Depending on how you define your collections, how you've populated them through your algorithms, you may choose to use indices of or values of, but those are certainly possible in Oracle 10G Release 2 and higher. Well, that's a lot of detail about the for all statement. Clearly, the only way to get a handle on all this stuff is to play around with it yourself. So first of all, realize that the for all statement has an incredible dramatic impact on the performance of repeated execution of the same DML statement. Anytime you have a for all statement, anytime you have a DML statement inside any kind of loop, cursive for loop, numeric for loop, etc., you should look to convert over to the for all statement and achieve at least an order of magnitude 10 times faster performance, perhaps much, much more than that. So look for every opportunity to use for all. Don't forget, if you have sparsely filled bind arrays, you don't have to convert them into, get rid of all the gaps and densify them. You can instead use indices of and values of. And most importantly, spend a lot of time with the for all statement. Try out my different scripts. Get really comfortable with it. Get comfortable with SQL% row count and bulk row count and how these operations work. And then you'll be able to apply them in a very flexible and productive manner in your code. Next steps. Like I say, download that demo zip. Try out all these scripts. Make sure you know this stuff and can use it easily. And then watch the next and final lesson in the series, in which I talk about how to convert from an old-fashioned piece of code, a loop with DML operations inside of it, to the modern bulk processing approach. And while it's not going to completely match up with the production level challenges you'll meet, in other words, you're writing production code, and I'm showing you demonstration scripts, that lesson should give you a pretty good idea of the kind of issues you have to deal with when you do convert for production quality code. I hope you enjoyed this lesson on for all, and happy PL SQL coding.